Hello, ladies and gentlemen. This is Mrs. Taylor, and I'm bringing you the 1.5 section for geometry, which is using formulas in geometry. We're going to learn and apply formulas for perimeter, area, and circumference. So in this video, I'm not going to pause. So I'll give a brief little 1, 2, 3 in my head to give you a chance to get to your pause button. But when you need to write something down, pause. When you're finished, keep going. That way the video will be as fast as each of you can do this individually. All right, so the first thing that we need to get into our notes is that the perimeter and the area of a rectangle are as follows. The perimeter is twice the length plus twice the width, or you can add the length and width together first and then double them. So that's the perimeter of a rectangle. The area of a rectangle is length times width. For a square, the perimeter is side plus side plus side plus side, which we can simplify to be 4s. And the area is side times side, which becomes side squared. Hopefully this isn't new. You've seen this starting in about 5th grade, but we might apply it in a new way. We will apply this in a new way. Now, this is the perimeter and area of a triangle. It says the perimeter is A plus B plus C, and the area of the triangle is A equals 1/2 times base times height, or the base times height divided by 2. Now, the one thing that I need to point out here is when you were in middle school or elementary school and talking about this, you would have seen triangles like this. Well, the height of a triangle is not always going to be inside the triangle, and now that we respect you more as mathematicians, we think that you're ready to see triangles that look like this. In fact, later in the year, we'll even learn to figure out what the height of a triangle is using trigonometry, and that's really fun. All right, so this first example has us find the perimeter and area of each figure, and we're given a rectangle and a triangle. Now, I want you to do both of these on your own, and I want you to pause the video, do it on your own, and then start the video when you're ready to see if you did it correctly. But I do need to point something out with the triangle. Now, this is Mr. Lozar's Widmapoy thing, where when in doubt, make a picture of it. So here's my picture, and I'm going to draw in my height because I notice that I have A, B, and C, but also a height. So I know that I don't have a situation like this where the height is one side of the triangle. So this is my triangle, and I'm going to call my height 6. The one thing that I need to be really careful of is B is going to be the base of the triangle. Notice in all of these formulas, we have the base times the height for the area. So when we're given this situation where we don't have a drawing, we're going to label the base, the thing that is perpendicular to the height. This part is going to be labeled as the base, the B side. And it doesn't matter if I call this 8 or I put 8 over here. It doesn't matter. I'm just going to go ahead and leave that there and label this side 4x. So at this point, I want you to go ahead and pause the video, figure out the perimeter and the area of both the given rectangle and the triangle. All right, so working with the rectangle, I'm going to go ahead and draw a picture of it as well. I don't think this is nearly as confusing as the triangle, but I think it helps. So the way I've got my triangle drawn, this side is the longer side. So I'm going to go ahead and label that 17 because 17 is bigger than 5, which means if that's my length, this is my width. We just wrote down that the perimeter of a rectangle was twice the width plus twice the length. So I'm going to go ahead and plug things in there. 2 times 5 plus 2 times 17. That would simplify down to 10 plus 34. So the perimeter of this rectangle is 44. I've got units. So I'm going to say that the perimeter of this is 44 centimeters, and I'm going to put a box on that. The next thing that we need to do is figure out the area of my rectangle. Well, the area is length times width. So the area is going to be 17 times 5. Maybe you need a calculator for that one. I think it's 85, and I do need units. Because it's area, I say this is centimeters squared or square centimeters. Either one of those will work. Okay, so let's get started on the triangle. I know that the perimeter of a triangle is A plus B plus C, so I'm going to go ahead and fill things in. A is 8, B is x plus 1, and C is 4x. At this point, all I need to do is combine like terms. So I have x and 4x. X plus 4x is 5x. And then I have 8 and 1, so that's 9. I'm not given any units, so I don't need units in my answer, or I could just write units. That would be acceptable, but I personally don't mark wrong if you leave off the units unless there are units given. If you're given units, then I do require them in your final answer. Okay, so the area of the triangle is 1/2 base times height, which I'm going to go ahead and fill in. My base is x plus 1, and my height is 6. Now, one of the things that you learned last year in Algebra 1 is that multiplication is commutative. That means I can change the order of multiplication to make it work in my favor. So I'm going to go ahead and rearrange the terms of this, because now when I've got it like this, I can do 1/2 times 6, and that's a nice easy thing for me. 6 is even, half of 6 is 3. So I'm going to say the area equals 3 times x plus 1. And, you know, I would not mark you wrong if you left it like that. Mostly, I think that you guys would do this and go ahead and distribute it. And then if you were going to put the units, you would do units squared. So that's my final answer for that one. Okay, so we have an application problem. The Texas Treasures quilt block measures 24 purple includes 24 purple triangles. The base and height of each triangle are about 3 inches. Find the approximate amount of fabric used to make the 24 triangles. Okay, so in quilting, there are a lot of these patterns that quilters just do. The log cabin quilt, the Texas Treasures quilt. I'm not a quilter. That is the extent of my quilting knowledge. But you would go out and you would pick the colors that you're going to use. So this quilter has some light blue and purple and red and yellow. So here's this one purple triangle. And our problem tells us that in this one purple triangle, I have a base and height of about 3 inches. Now I notice that these are all squares in here, so I know that this is a right angle, and I should tell you that that's a right angle. So let's see. The area of one triangle, a subtriangle, that's my notation for saying the area of one triangle, is equal to 1/2 base times height. So I'm going to go ahead and plug things in. The area of one triangle is 1/2 3 times 3. So there's no amount of rearranging this to make this nicer or prettier. 3 times 3 is 9. So I do 3 times 3 is 9, and 9 times 1/2 is 9/2. I know a bunch of you will be uncomfortable with that and plug it into your calculator to get 4.5. And we do have units on this, so I'm going to say square inches for this. The question doesn't ask us how much or what the area of one triangle is. The question asks us, what's the area of 24 triangles? That's what the question asks. Well, if I multiplied this right here by 24, I would also, because of algebra, have to multiply this side over here by 24. So I'm going to say 24 areas of a single triangle is equal to 4.5 times 24. And this is where I wish I were working with fractions, because I can do fractions in my head. So the area of 24 triangles is equal to 108 square inches. It's an application problem, so we're going to write the answer in the form of a sentence. So the question asks us how much material would be needed for these 24 purple squares. So I'm going to write the quilter needs 108 square inches of purple fabric for 24 3 by 3 inch triangles. If you chose to write that sentence differently, but it contains all the information in it, perfectly fine. All right, moving on to circles. So the diameter of a circle is a segment that passes through the center of a circle and whose endpoints are on the circle. So the diameter is this guy right here. It passes through the center and its endpoints lie on the circle. The radius is a segment whose endpoints are on the center of the circle, and the radius, and it's the segment that connects those. And there are literally an infinite number of radiuses in here. So I can take this and I can kind of twirl it around. Oh, apparently I can't twirl it around. Disregard. That bit of smartboard magic isn't working. But there's radiuses that go from the center to the outside of the circle all over the place. So these are all radiuses or radii. Last up, the circumference is the area or the distance around the circle, not the area, but the distance around the circle. So if you were going to walk around the circle, boop, 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 all the way around, how far would you walk if you walked around it? Okay, that's those three terms. The next up, I need you to put in your notes that the circumference C of a circle is given by the formula capital C equals pi d, where d is the diameter, or capital C equals 2 pi r, where r is the radius. The area of a circle is given by the formula capital A equals pi r squared, where r is the radius. The ratio of a circumference to the diameter of the circle is the same for all circles. So it doesn't matter if I have this little baby circle right here, or let's see if I can do this, or if I have this medium-sized circle, or if I have this really enormous circle. If I take the circumference of the circle and I divide it by the diameter of the circle, regardless as to how big the circle is, you're always going to get something that comes close to 22 over 7, which is 3.1415, blah, 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 out into infinity, right? That's the magic of pi, because it's the same thing, whether we're looking at a regular size, a medium size, or an enormous size circle. All right, so this is a relatively straightforward example. It says find the area and the circumference of circle. Now, the twist on this one is they want the answer in two different ways. It wants the answer rounded to the nearest tenth and in terms of pi. And this is going to be new for you this year. I don't think any of you who have ever seen answers in terms of pi. So let's see. We need to find the area of the circle. So according to our last slide, the area of a circle is pi r squared. I'm given r in this particular case. R is 3. So I'm going to fill in r with 3. Now, if you remember your exponents, and I know that you do, you know that that exponent only belongs to the 3. So you're going to do 3 squared. So in the next line, you're going to have pi times 9. Pi is not a variable. It's not a variable. It's not like x or y or m. It is a symbol that represents one exact number. However, like when we talk about variables, we put the number first and then the variable. Well, pi isn't a variable, but we're going to write it second. So that means on the next line, I'm going to write a equals 9 pi. Now, I'm going to go ahead and throw my units on there and say I'm finding an area, so it's going to be square units, and my problem has centimeters. So I'm calling this centimeters squared. This right here is my area in terms of pi. That's one of your answers. When you take the quiz in a couple of days, you're going to have a problem just like that, and there's going to be 2 answer blanks. You're going to put that answer on one of them, and then you're going to pick up your calculator. I guess I better find a calculator. And you're going to type in 9 times, and you're going to find your pi button. And boy, I wish I knew where that was on this. There it is. So 9 times pi and hit enter. When I hit enter, I get this. I get 28274333888. But the question doesn't want all that junk. It says rounded to the nearest tenth. So I say, okay, the nearest tenth is the first digit to the right of the decimal point. So I'm looking at that number. Is 7 big enough to cause me to change the number in front of it? 5 or more causes the number in front to change. So my final answer is 28.3. They're still centimeters square, and this is my area rounded to the nearest tenth. Okay. Fantastic. We're halfway done. We have to do the perimeter, not the perimeter, the circumference, sorry. So the circumference of my circle is 2 pi r. Now we could do pi times the diameter, but my question doesn't have a diameter. My diagram doesn't have a diameter. So I'm going to use this one. I'm going to plug in 3. Multiplication is commutative, so I can put the 2 and the 3 right next to each other, or I can just say in my head, what's 2 times 3? And the answer is 6 pi. This will be my answer in terms of pi. My units for this are linear units, so just centimeters. So this is my answer in terms of pi. Now I pick up my calculator and I say 6 times pi. I need to round that to the nearest tenth. So my circumference is 18.849555592, but I don't care about all that stuff. I'm looking at this digit and this digit. That 4 is not big enough to cause me to round up. So my final answer is 18.8. My units are centimeters, and this is my answer rounded to the nearest tenth. All right, the next one says the area of a circle is 64 pi. We need to find the radius and their circumference. And it says express your answer in terms of pi where necessary. That means pi will be in my answer. I don't have to pick up my calculator. All right, so the first thing that I need to do is kind of convert this right here. The area of a circle is 64 pi. Well, if I were to make an algebraic expression out of that phrase, I would say the area of a circle is equal to 64 pi. Okay, so that's my expression. We already know what the area of a circle is. On this slide, it says the area of a circle is equal to pi r squared. So what I'm going to do is I'm going to take out the a and put in pi r squared. So I'm going to take out this a, and in its place, I'm going to put pi r squared. And then I'm just going to bring down what's on the other side of the equal sign. Okay. Now I'm going to go ahead and do what I have to do to figure out what r is, because it says I need to find the radius and their circumference. So right now r is being multiplied by a number. If I had 4x equals 16 and I said, how would you get the x alone? You'd say, Mrs. Taylor, you're going to divide both sides by 4, right? So this is what you would do. In this case over here, we don't have 4, we have pi, but it is just a number. So I'm going to divide both sides by pi because I can do that. It's just a number. All right, pi divided by pi is 1. Anything divided by itself is 1, which means I get to cancel these guys out here and here. And what I'm going to be left with is r squared equals 64. Last year in Algebra 1, we learned that to undo any operation, you use the inverse operation. We learned in the chapter on exponents that the inverse operation of squaring something is to take the square root. So in order to figure out what the answer is, I'm going to take the square root of r squared. Anything in algebra I do to one side, I have to do to the other. So I'm also going to take the square root of 64. The square root of r squared is just r, and the square root of 64 is plus or minus 8. But here's the thing. At the very end of school, the last week of new instruction, we talked about this, and we said, listen, we have these when we have parabolas, when we have squared quadratic formula or quadratic equations, we'll have two answers, and we will very often have what are called extraneous answers. And what that means is one of them won't make sense. Can I have a circle where the radius is -8? No, I can't have a circle where the radius is -8. So my answer is just r equals 8. There's no units given, so that's going to be the end of that. So I have figured out, find the radius. The radius is r equals 8. The next part of the question says, find the circumference. Well, 2 slides ago, we wrote down that their circumference was equal to 2 pi r. So I'm going to go ahead and plug in r, which is 8. We can rearrange the numbers to make them suitable to us. So 2 times 8 is 16 pi. It says express your answer in terms of pi where necessary. So we can put a box around that and call it finished. The radius of my circle is 8, and the circumference of my circle is 16 pi. All right, I'm not going to dwell on that because it may be different. That's today's slideshow. If you have any questions, find one of us and ask away. Thanks so much. Bye.